Today I want to make something called 2-methyl cyclohexanone, which is a reagent that I need for an upcoming video. I could have bought it directly for cheaper and less effort, but I thought it would be fun to do the synthesis myself and show you guys how it's done. To do this, I need several reagents. What I'll start with is cyclohexanone, which is very similar to the molecule I want. But unfortunately, I can't just throw a methyl group at it and make it stick in the right place. So first, I have to change the molecule to make it suitable for adding a methyl group and also make it in a way so that the methyl group goes to the right position. To make this happen, I can transform the ketone of the cyclohexanone to an enamine by using something called pyridine. Since the enamine has resonance, meaning it switches back and forth between structures, one of the two structures reveals that the carbon is strongly nucleophilic, evident by the lone electron pair on that carbon. Because this carbon is nucleophilic, it can attack an electrophilic compound, in this case methyl iodide. Because iodine is so electronegative, it loves to hold on to electrons, which means that the bond between the iodine atom and the methyl group is polarized. The electrons from the bond hang closer around iodine, which causes the iodine side to be more negative and the methyl side to be more positive. Because the methyl group side is positive, the nucleophilic carbon can attack the methyl iodide and steal its methyl group. Afterward, I can add some water and acid to kick off the pyridine and return it back into a ketone. Afterward, I can simply distill the mixture to get my 2-methyl cyclohexanone. So let's get to it. So these are the three main reactants that I will use for this reaction. First, I will open the can that contains the methyl iodide bottle. Now, I will build a Dean-Stark trap before I can start the reaction. The purpose of a Dean-Stark trap is to remove water from the mixture. Since the reaction between cyclohexanone and pyridine produces water and is a multi-step process which are all in equilibrium, I want to force the reaction to completion by removing water from the reaction mixture. The Dean-Stark trap can trap water that is produced during the reaction. The solvent, in this case toluene, will form an azeotrope with water, which means they will boil off together at the same temperature in a certain ratio. So the condenser above the trap will condense the vapors of the azeotrope, which will flow down into the lower part of the trap. Because water is denser than toluene, the water will sink to the bottom and collect there. Since the top layer is toluene and toluene is constantly being added to the trap, it can overflow back into the reaction flask, and this way the volume of toluene in the reaction flask stays mostly the same. Because the reaction is sensitive to oxygen, I flush the apparatus with argon. Normally you can do this reaction under constant argon or nitrogen flow, but since it takes 24 hours I'm not going to do that. So to start the reaction, I first add 100 ml of cyclohexanone to the flask. Then I add 120 ml of pyridine. Since pyridine stinks and gives off a lot of vapors, I put the window down, and as you can see, even the tiny bit of pyridine that was left in the graduating cylinder produces a lot of vapors. Then I add 150 ml of toluene that I made in my previous video, which I redistilled and dried. Then I quickly closed the flask to block the vapors, and after a little while I decided to add a small scoop of para-toluene sulfonic acid to improve the reaction. Since my reactants aren't completely dry, this will help water separation. So after a while, both the pyridine and the toluene are condensing and falling into the trap. Because of the argon flow, the pyridine vapors are forced out of the top. Normally you would fill up the Dean Stark apparatus fully with your solvent, but I actually ran out of toluene, so I didn't do it, but it shouldn't matter too much. I then remove the argon flow and replace it with a stopper. One problem that occurred to me during the reaction was the fact that pyridine is also miscible with water, which means that the water probably won't collect properly and instead just mix with the pyridine in the Dean Stark apparatus. Since there's quite a lot of pyridine in the flask, it would also mean that the pyridine water mixture overflows back into the flask. But at the same time, water is also constantly removed from the flask, but I have to see how it influences the yield. Anyhow, I leave it to reflux for 24 hours. So I come back the next day and the mixture has turned red, which is probably from oxidation from the air. So now I poured the mixture into a different flask and I changed the setup to a vacuum distillation. The mixture has turned even darker due to contact with the air. Since the anamine is so unstable, it oxidizes quickly, but since I likely have a decent amount, it shouldn't matter too much. Because I don't want this oxidation product during the next step, I will have to completely boil over everything until the flask is dry. I adjust the vacuum and temperature to make sure that it boils continuously without boiling over into the condenser. So now it is mostly collecting toluene and pyridine, and after a while I poured it out and started collecting the next fraction, which should contain cyclohexanone and my anamine. And in the end, everything has distilled over and all that is left is some oxidized junk. So I stopped the vacuum distillation and let the air back in. Somehow the junk hadn't oxidized enough yet, and it started to form dense vapors in the flask. Anyhow, that goes straight to the garbage, and I'm left with a mixture that is mostly cyclohexanone and the anamine. Since cyclohexanone doesn't partake in the next reaction, it is not necessary to remove it yet, and after the reaction, when I want to collect the 2-methyl cyclohexanone, I can separate them anyway. Now I start building a regular reflux setup. Before I attach the condenser, I drop in a stir bar and add 150 ml of cyclohexane to the flask. Then I add 48 ml of methyl iodide and attach the condenser and bring it to a boil. But at this point I was scared by what I saw. Somehow it started producing some nasty floaty bits and I didn't know what it was. At this point I was afraid it was going to fail and make me waste all of my chemicals and time. As the reaction went on, more and more solid stuff started to appear, and for a little while it was refluxing, but quickly it seemed like only solid stuff was left over, and I was mentally preparing myself that it could be ruined. But in my last hope to save it, I started doing the workup anyway. So first, I had to add some water to the mixture. The water should react with any remaining anamine and convert it back into cyclohexanone and pyridine. And after adding the water, I was very relieved by what I saw. All of the solid stuff luckily started to disappear and dissolving into the water. And now, I was left with 2 layers. And the next step is to add some 10% sulfuric acid. This should destroy any remaining pyridine, but not much happened and I moved on to the next step, which is separating the 2 layers. At first, only the top organic layer poured out, and I just drain it directly into a beaker. Then I poured in the rest, which separated nicely into 2 layers, and I drain the bottom layer into a new beaker. Now what I have to do is extract the aqueous layer, which I will do with some DCM. But this is the part where I somehow managed to mess up. I poured the organic layer into the separatory funnel and added the DCM, which both just mixed and didn't really do anything. So since I didn't have all that much DCM, I didn't want to use too much of it. Since the organic layer is now diluted with DCM, I just poured the organic layer with the aqueous layer and hoped that the DCM would still pull out product that was left behind in the aqueous layer. So anyway, I get to shaking and I do this extraction a few more times and separate the layers. Then I take the organic layer again and wash it with a 5% sodium thiosulfate solution. I discard the sodium thiosulfate solution in my beaker with the aqueous layer and drain the organic layer into another beaker. After washing everything, I am left with about 400 ml of solution, which I will dry by pouring in some sodium sulfate and mixing it around. After letting it sit for a while, I filter the solution through some cotton and sea light. After everything is filtered through, I am left with a clear yellow solution. Now I pour the solution back into a flask and start distilling over everything and separating them into fractions. At first, I expect only DCM and maybe some remaining water and toluene to come over, which will collect in the large flask. After it is filled up, I empty it and start collecting more until it stops coming over around that temperature. Then I turn the cow adapter and increase the temperature to start collecting the next fraction. After a while, I turn it to the other side and collect the remainder in the other flask. When basically everything is boiled over, I stop the distillation. So now I am left with 3 flasks, which all might contain part of my product. I discarded the first full flask that came over since it was mostly just solvent, but the other fractions are somewhat overlapping. I decided to combine all of them and redistill them to get a good separation. This time I set up a short path distillation, because it is easier and it minimizes losses. The first fraction came over up until 110 C. I keep collecting more and swapping the flasks until I reach the boiling point of my product, which is 163 C. The boiling point of cyclohexanone is 156, which we are starting to see coming over now. After a while, I was relieved to see the temperature reach 163, and I swapped the flask to collect the 2-methyl cyclohexanone. When the temperature started to drop, I removed the flask and put on a new one, but the distillation was basically finished since almost everything had already come over by now. So I stopped the distillation and I am now left with my 2-methyl cyclohexanone, which I will use in a future video. What's interesting is that this compound somehow has a weird peppermint and acetone smell. I thought it smelled faintly of peppermint, and when I asked my dad to smell it, he said it smelled a bit acetone with a bit of peppermint, which funnily enough is exactly what is said online. So I'm fairly certain that I at least have my product here and not something else. Before I will use it for another project, I will likely redistill it and dry it on molecular sieves. For now, I will store it in a small container and use it when I need to. It seems that I got about 20 to 25 milliliter of product, which makes a terrible yield of about 20%. Since I didn't properly follow the protocol, it is kind of expected. For the first reaction, they used benzene instead of toluene, and in the second reaction they used toluene instead of cyclohexane. Unfortunately, it took so long for the solvents that I ordered to get delivered that I ordered some substitutes which arrived earlier. Also, in the original protocol, they performed the first reaction under constant argon flow. My water separation was also not really working because of the pyridine mixing with the water, which wasn't mentioned in the protocol, but I read online that it's possible to put a drying agent in the Dean Stark trap and remove the water that way. Anyhow, I don't need that much of the product, so I'm just happy that it worked out.